Welcome to our Chapter 3 lecture. We're going to talk about alkanes in this chapter and their stereochemistry. So we'll be dealing with what alkanes are, their properties, how to name them, as well as the way their atoms are arranged in 3 dimensions. That's what stereochemistry is. But before we actually do that, we're going to talk a little bit about functional groups, and that's just the way we classify organic molecules. So the alkanes chapter is a good time to do that, since alkanes are sort of the baseline where we start with organic molecules. We can build functional groups on top of an alkane skeleton. So a functional group itself, just a group of atoms with characteristic chemical behavior. So it's important for us to understand that it's the functional groups themselves that determine what type of reactions can happen with organic molecules, and that's nicely demonstrated with these 2 molecules. Look at ethylene here, just 2 carbons and a double bond, and then this more complex molecule, menthene, several more carbons, but it has a similar double bond right in its structure there. So both of these molecules have a similar functional group. When bromine, Br2, is added to either of these molecules, bromine adds to either atoms of the double bond. And that's the same case in ethylene as it is in this more complicated, larger molecule. So essentially the same reaction happens with these 2 molecules, regardless of their size and the complexity of the molecule, because they have similar functional groups to them. So we're going to take a functional group basis in learning types of organic reactions. We're going to sort of classify molecules by their functional groups and talk about the reactions that those types of molecules undergo. So let's just start with some real simple functional groups. The one we saw in the molecule up above was a double bond. So an alkene is a molecule that contains a CC double bond. So ene, that ending, we'll see that the ending of a molecule's name is characteristic of the functional group that it contains. So an alkene has a double bond. Look at these molecules we had up here. Ethylene, it ends in ene. Menthene ends in ene. So the ending of the molecule tells us what kind of functional groups are present. I have a picture here, electrostatic potential map, that shows the perimeter of this ethylene molecule. The hydrogens on the outside are fairly electropositive. They don't have too much electron density, but there's this red blob concentrated around the double bond. So there's extra electron density where that double bond is. That's going to be important to us later on. So reactions will be able to start with some of those electrons in that double bond. So alkene has a double bond. Alkyne, A-L-K-Y-N-E, is a compound with a triple bond. And an arene is a compound that has a benzene ring. Right? This one I've shown here is a benzene ring, 6 carbons, alternating double, single, double, single, double, single in them. We'll learn in second semester that there's actually such thing as other rings that have what's called an aromatic property to them. So any aromatic ring makes the molecule an arene, but benzene is the most common of them. So let's take a look just at a couple of functional groups where there's an electronegative atom bonded to a carbon. This is very common. Look at this alkyl halide here. There's a carbon and a chlorine or any other halogen atom that's bonded to it. If it's more electronegative than carbon, it will withdraw electron density through that inductive effect that we talked about in the last chapter. And look at the electrostatic potential map here. Around the carbon, it is turned blue. It is fairly devoid of electron density, so that means that carbon will have a partial positive charge to it. Same thing with this alcohol. We have an OH attached to this C. That makes the C partial positive. Here's an ether, an oxygen in between 2 carbons, in which case the oxygen withdraws electron density from each of those carbons. In each case, the map shows more color around the electronegative atom. Around these oxygens, it's become quite red, especially where their lone pairs are. The remainders of the molecules are quite devoid of electron density. They've had their electrons sort of pulled away from them through that inductive effect that we talked about before. So Let's talk about another class of functional groups, those that contain a carbonyl. And that's how it's pronounced. C-A-R-B-O-N-Y-L is pronounced carbonyl. A carbonyl group is anything that has a CO double bond. So the CO double bond, in fact, we call that a carbonyl very commonly. So, and there's all kinds of functional groups that contain a carbonyl. Look at this aldehyde, characteristic because it has a hydrogen attached to the carbonyl. Ketones have two other hydrocarbon groups, two other alkyl groups attached to the carbonyl. Carboxylic acid has this OH group attached to the carbonyl. Ester has an O and then another alkyl group attached to the carbonyl. And then there's other ones. We won't worry too much about thioesters right now, but amide will come in handy for us later on. It's an N with whatever attached to it that's on the C double bond O. An acid chloride, just like a carboxylic acid, except there's a chloride instead of the OH. Those carbonyl groups will be important to us because, well, that oxygen is more electronegative than the carbon. In each case, these carbons will have a partial positive charge to them. So that's going to be important to us later on when we're learning about how it is that reactions behave containing these functional groups. For now, you should have a basic familiarity with these functional groups. We won't dwell on them. We won't learn about their properties until later on. But for now, have just a basic familiarity so that when you see them as they come up in the future, you'll be able to identify them. The monophosphate group will come up a couple of times when we talk about biological molecules. So ADP, ATP, things like that. We'll have that important functional group. An amine just has an N attached to whatever the carbon is. So some of these other ones are a little less common, but we'll deal with a lot of these as we're going along in here.